Hello everyone, my name is Sean Lacey of Lacey Maths and Stats Consultancy, and this video is a demonstration on doing the F-ratio calculation in Excel for the TwoWay ANOVA. So this video is a follow-on from my previous video that I've up on YouTube, which is the F-ratio calculation in Excel for a one-way ANOVA. So in this video that's already up on YouTube, there is, I suppose, kind of a slower, a steadier pace at it, kind of working through, look, what does it mean to say the sum of squares, the degrees of freedom, and the mean square, and then ultimately how do we get the F ratio. For this video here, I'm going to just, I suppose, move through those steps a bit faster because I mainly want to kind of get to, I suppose, how do we do all the sums of squares calculations. Since it's a two-way ANOVA, what that ultimately means here is that there's a measurement and then there's going to be two factors. And what I found when I look at different videos up on YouTube or different documents just up on the internet, that when it comes to the sums of square calculations, what I find is they do the sum of square calculations for the factors by themselves, for the within, and for the total, and then they look at the overall combination and then work backwards to get what the interaction one is. And look, that's obviously fine, but I think it's good for a researcher to just understand maybe where the sum of squares for the interaction effect actually comes from. So that I suppose maybe that's what this video might be a bit different to other maybe videos already out there, okay? And like I said, this is going to be a follow-on from the one-way ANOVA that I would have done before. So these are all the calculations that would have been done in the other video. And look, this is ultimately deriving the one-way ANOVA. So for the one-way, it's where you have a measurement with respect to a factor, and the factor had more than two levels, and our factor in this case was group and it had 5 levels. For the two-way ANOVA, there's a measurement. There's no context to this. I want to kind of keep it as general as possible. There's a measurement. The measurement is then carried out, I suppose, 50 times. There is a grouping variable. Okay, so there's grouping factor that has 5 levels. There's a type factor that has 2 levels. So that what that would mean here is that there's 10 types of experiments. So then within each type of experiments, there's 5 replicates. That's kind of the idea to this. Okay, so okay, it's, again, I'm trying to keep it as broad as possible to maybe make it applicable to your own kind of research. And I suppose again the emphasis is just basically how do we complete this table. Okay, if you're unsure about sum of squares, what it means, degrees of freedom, and mean square and F ratio, I'd recommend maybe just going back to my other video first, watching that, just to kind of get up to speed on that, and then you can kind of just see where this is going. This is just adding on another layer to it, okay? So there's numerous ways that we can approach this, and I was trying to think of, look, what way could I do it as, I suppose, as tidy as possible in Excel for the video. So the first step I'm going to do is I'm actually just going to work out all the means, okay? So what we're going to actually have here is we'll have a mean for group A, mean for group B, C, D, E. We'll have a mean for type 1 and mean for type 2, and then we'll have a mean for each of the 10 types of experiments. So overall, there's a good few means to actually be working out here, and that's because we have 2 factors. And you can see then if you step this up to 3 factors, there's obviously going to be a lot more work involved in that, which is basically going to be the similar idea to this one, but obviously just a lot more calculations. And it's not that I'd recommend that you always have to go off and doing everything by hand, but it's just have, I suppose, an appreciation for the process. What's the main statistical package, whether it's RStudio, SPSS, Minitab, SAS, Python, whatever you're using. What is it doing for you when it's actually giving you an ANOVA result? I suppose that's just the focus for this one. Okay, so here I'm just going to work out the average for the first type of experiment that I have, which is just going to be group A down here. So this is group A type 1. I'm going to get the average for that. And then I'm going to get the average for, sorry, I spelled that wrong, E or AGE. I'm going to get the average then for the next one here, like that. And then I'm just going to copy them across, and that should all work out nicely here to this, and it is. Okay, I'm not too sure why those errors are there, so I'm just going to ignore those errors. That should be just probably just some messing I would have done with the Excel file before. Okay, so that's basically these are the means for each of the 10 types of experiments. So the experiment when group is at A and type is at 1, and then so on like that. Okay, so the next thing I want to just do is I want to work out, look, what is the average for the A group. Okay, so there's 2 ways I can do it. I can get the average of these 10 numbers, or I can get the average of these 2 numbers. It'll obviously give me the same answer. So I'm just going to keep it quite short, and I'll do the short of 1, which is going to take the average of these 2 numbers up. But obviously the other one will work out fine. I'll do that, going across, and just even as a sanity check, you can say, look, are they right? If I go back to the one-way ANOVA in the previous video, you can see where are they here. I was just looking for them. You can see that they're the values there that I had for the one-way, and obviously they're the same here. They must be, okay? Then if I was to do the type, so this is going to be what was the average for the type, so that must be the average of these here. Or I could take the average of the 25 type 1 measurements that I have up here. They'll both give me the same. Obviously you can just see there that I typed in sum as opposed to average. And I'll just do that here. That's perfect. Then do it here as well. And then you could look at this average of everything. Loads of ways again that we could do this one. EV, ER, AGE. We could do it this way. We could do rows, columns. Actually, for this one, just to do something different, I'm just going to actually highlight all of them. It doesn't make any odds. It's all actually defined, all the same. Okay, whichever way. So when I'm saying I could get the average of these 10, these 5, these 2, or the 50 up there, and it will basically always give me 11.06 in that case. Okay, so that's just basically, it actually just helps a small bit actually working out all these averages. So the first thing I'm going to do now here is I'm just going to work out the sum of squares for the between factor, which is going to be called group. Okay, so the grouping factor. So I'm just going to focus on group first. So if I just focus on that here, and what we want to do here is we basically want to work out the sum of squares. Okay, so the sum of squares is the difference between the mean and the overall. So the group mean, or which in this case is group A mean, and the overall mean squared. Okay, so if you're to do that here, this will be this group mean. So this is group A minus the overall mean. Then I'm going to square that. I want to copy that across. So when I do that, I want to lock this guy here. So that should work out fine. Then I bring this all the way across, and there are my 5 means then in that case. Okay, if I wanted a quick check, did I do that correctly? It's basically taking this mean, 13, minusing the overall mean, and then squaring the answer. That would be the sum of squares. Sorry, that would be the square of the difference. Now I want to work out the sum of squares. So the sum of squares is essentially this. Okay, you're summing them up, but then you need to multiply it by the number of replicates for that type of experiment. So if we think of the group A experiment, there are 10 replicates within A, there's 10 replicates within B, and so on like that. So when you're doing the sum of squares up here, it's going to be 10 times the sum of your squares, which are these guys down here, and that's that. Okay, so we've got that done good. Then you have your degrees of freedom. The degrees of freedom is the number of levels less 1. So in this case here we had 5 levels, so 5 levels less 1 is going to be 4. Then it's the mean square. So the mean square is just your sum of squares divided by your degrees of freedom, and we're going to get that result back. Okay, so now we're going to move on to the next one. The next one is going to be the type. So I'm just going, so that was group, wasn't it? Yeah, that was group. So now I'll do type. Similar one, except obviously it's just set up a small bit different, as in I have it down as a column here. But ultimately what this is where you're looking at the average for type 1, the difference in that average with respect to the overall, then squared. Okay, so we're just going to do this one equals this minus, so that's the average for group type 1 minus the overall average. Then we're squaring that here. I want to copy that down, so I need to lock the row this, or sorry, yeah, the row this time. So if I copy that down, that's the second type. Okay, so I just if I double click on that, you can see, look, it's taking 11.36 minus 11.06 and then squaring the answer. Now these are my two squares, as in the squares of the differences. I want to sum them up, and then I multiply by the number of replicates. Now the number of replicates for each type of experiment, well, when you're looking at type 1, there were 25 replicates for type 1. Then there was 25 replicates for type 2 as well. Okay, so this will be 25 times the sum, sorry, just type it in, times sum of these two guys here, and then we get that back. Okay, what are the degrees of freedom? Well, the degrees of freedom is your number of levels less 1. Here for this one, we're looking at the type, we need 2 levels, so less 1 is 1, and then we obviously just do the same division technique that we did the last time, and this is where we end up with. Okay, so often then when I look at I suppose resources online, I see what they seem to generally go is to the within, or which is the error or the residual, all depending which you want to call it. They go to that and then they work out the total, and then they kind of work backwards to get the interaction. But here I want to actually just do the interaction. It does take a small bit of time, but I think it's just worth kind of seeing where the numbers are coming from. Okay, now the reason it takes a small bit of time is ultimately, like, you're looking here at the interaction between two factors. So you're actually looking at kind of subtracting the means off twice, but then you can't subtract means off twice. You need to kind of balance it out by adding on a mean as well. So there's a small bit of work into this, but it should be fine. So if we look at the first one, so what we're going to do is we're going to focus on our first interaction. Okay, so this is A with 1. Okay, so group A with type 1. So this is the mean. So then what we do then is we minus the mean for the group. Okay, so for that type. So we're minusing the overall mean for type 1, minus the overall mean for group A, and then we add the overall mean after that. That's the approach to this. Okay, so we're focusing on the mean, so the average for the experiment of where the setting was group A type 1. We take that one, we minus the mean for type 1, the overall mean for type 1, we minus the overall mean for type A, and then we plus the actual overall mean. So that's our differences in this case, and then we square that and we get this back. Okay, then we want to copy that. So when I'm copying this, what do I want to do? I want to fix the column, isn't it? I want to fix this one, and yeah, I want to fix this, I want to fix this, and then I want to fix these two here like that. Okay, so I'll just do this across, so I'm doing it all the way across here like that, so that's 5, isn't it? That's what I have. Now I'll just do a quick check. So when I'm looking at this one here, this should be, if I wanted to work out what is the sum of squares for this interaction effect, okay, so this will be, the squares for this interaction effect, it should be the 11.36 minus 13 plus 11.06, that will be it. Okay, so if I double click on this here, I should see that that's what's going to be highlighted, and I can see that here. So it's blue minus the red minus the purple plus the green. Okay, that's the way that's working out. And they're basically the squares. Okay, so they're the squares now in this case, so the squares are the differences. Then we want to sum them up, and that's what we put in here. But then when we put that in here, we always multiply by the number of replicates. So how many times was each type of experiment carried out? Well, here we had 10 experiments. That's what we actually have. We have 10 experiments. So there was 5 replicates for each experiment. So this is going to be equals 5 times the sum of these 10 guys here. You can see the answer is going to turn out to be quite small, and this is what we end up with, 40.8. Okay. Then the degrees of freedom. So the degrees of freedom is basically the degrees of freedom for your factors multiplied by each other. Okay, so the degree of freedom for the group factor was 4. The degrees of freedom for the type factor was 1. So 4 times 1 is actually going to be 1. Sorry, 4 times 1 is going to be 4. So that's where we get this from. And then we divide, then we do the same division, so it's the mean square divided by the degrees of freedom, and that's where we come back with, okay? So I just find that this is the real reason I suppose I wanted to do this video, was just to kind of show this calculation here, because you don't see that often in many videos out there, so hopefully you might find that that's a help. The rest then is very straightforward, okay? So it's just, I'll quickly go through it. It'll just be the within. So when you're looking at the within, so in this case here, what you're looking at is within each type of experiment. So here we've 10 types of experiments. So here, so this is the first type of experiment, and then we've the other types of experiments and so on, obviously. Okay, so within each type of experiment, what was the actual variation is what we're interested in here. Okay, so in this one here, we're looking at type group A. So I'm just going to put this in, here. We're looking at group A, so this cell here, minus the mean for that type of experiment, which is actually the first mean that we have here, and then I'm just going to square that, and that's what I get back, okay? And then I want to lock this when I'm doing my copying, isn't it? This one is what I want to lock. I'm going to bring this down 5 times here, and this is where I have this. If I do a quick check, then this should be my 5th experiment here, minus the actual mean, and that works out fine. Okay, so what we're looking at here is within each type of experiment, what was ultimately the difference, okay, or the squared difference is what we're interested in here. Okay, so if we take again, I'll just move on to the next one here and I'll explain that step again. So here I'm looking at my second type of experiment, which is going to be group A type 2. Okay, so I take that, I minus the mean for that here, which is the mean for that type of experiment, and then I square it. Okay, now I could obviously do that then for each cell. I'm just trying to save myself a small bit of work, so I'm just copying, I'm locking that cell, and then I'm just copying it down 2, 3, 4, 5 like that. Okay, so it's just saving me retyping everything. So if I click on this entry, what this should highlight then is should be 8 minus 6.8 and then squared, okay, which is obviously going to be correct here because I can see the answer is 1.44. So it's 8, which is that type of that particular experiment, minus the overall mean for that type of experiment. That's the difference, and then you square it. Okay, so that's where you have the 10 there in this case, and then put that across here like this, and you'll end up with these. Okay, so you do that for all of them then. So if I just want to do a quick check just to show that this is correct, if I click what's the difference here, so this is going to be 12 minus the mean for that overall experiment, which is going to be 13.4, and then squared. So if I click on this one here, I should see 12 minus 13.4 squared. Okay, now again, if you're unsure about that within, just maybe go back to my other video if you wanted to, and I kind of just talk about it a small bit more in that case. Okay, then we just want to sum them up. There's no multiplying by the replicates here, it is just summing up the squares within. So we're just going to take this one here, and this is what we have. Okay, there we go. Okay, so we end up with 390. Then it's your degrees of freedom. So your degree of freedom is going to be your sample size minus, I suppose, the basically it's what way would you say it? Well, look, I'll say it this way. Okay, so what we actually have here is if we look at each one of these, we've 10 types of experiments, I suppose. Okay, so we've 10 types of experiments. Each experiment is carried out 5 times. Okay, so that means the degrees of freedom for each type of experiment was 4, and then you do that 10 times. So that would mean that your degrees of freedom in that case would actually be 40. Okay, so that's where that's coming from. Okay, so in this case here, it is, look, I suppose I'd say it two ways. Okay, so degrees of freedom here would basically be, if we've 10 experiments. Okay, so within how many measurements do we have within one experiment? Well, we have 5 replicates, we said, so we have 5 measurements within one experiment. So that means that the degrees of freedom within one experiment is 4, and then we had 10 types of experiments. So that's where 40 is coming from. Okay, so that's one way of looking at it. The other way of doing it then is where you can take your sample size. So we have a total sample size of 50, then minus the number of levels that you have in each factor, at the product of the levels you have in each factor. So if you look at group A, it has 5 levels. If you look at type, it has 2 levels. 5 times 2 is 10, and then 10 from 50 will give you back 40 as well. Okay, so there's the two ways of looking at it, and I won't repeat it. If you need to repeat it, you could just rewind it there if you want, and then you come back down here, and this is the same process, okay, here for this one. Now, you could maybe you might be nervous and kind of saying, oh, am I doing that right? So there is two, I mean, we often see this summing up. Okay, so this is where you see a lot of videos would do something like this. Okay, you can sum it up. I'm just going to verify that we have actually done this correctly. Okay, so the degrees of freedom is an easy one. The degrees of freedom for your total, if we were to do a total, I'm going to just do a separate one here. Now, you often don't need this for your actual ANOVA, but I suppose if you're doing the calculation manually, how do you know you've done it correctly? Now, I'm ultimately going to show you the RStudio script anyway, but just say if you didn't have the RStudio script, how do you know you've done it correctly? Well, this one here is going to be your degrees of freedom is your overall sample size less 1, so that's 50 less 1, which is obviously going to be 49, so that's fine. Okay, so there's no big deal with that one. And here I'll just call it the total here, so TOTAL. So this one here then, so this is where you look at each individual experiment, you work out the difference from each individual experiment and the overall mean, and then you square that difference. Okay, so if I was to look at this one here, I'm just going to go to the first experiment we have, which was this one. I'm minusing the overall mean. The overall mean was 11.06, and then I'm going to square my answer, and that would be that. Okay, I want to copy that across, so I need to lock the row and the column in this case, and then I go 2, 3, 4, 5, 2, 3, 4, 5, 6, 7, 8, 9, 10, like that. Okay, so that's all, I suppose, the square of the differences from each experiment and the overall mean. And then if I just sum them up, I should get the same. And if we don't, it should look, there's obviously a typo somewhere then, but we will get the same here. If we do that, we end up with this, and we can see it's the exact same. Okay, so I feel, look, that's quite nice. Now, often what I'd find in the videos, and this is what I said earlier, is I would find videos online would actually do this calculation, then they do this one and this one. Sorry, not that one. They do this one, and then they'd basically say this total minus the within minus the type minus the group will give you the interaction, and which is obviously correct, but I just think it's nice that you know how we're actually getting the interaction. So that's why I want to do this. And then the last step then is the F ratio. So we would have said this again in the previous video, but the F ratio is basically going to be your mean square between divided by your mean square within. Here we have 3 mean squares between, so we're going to take each individual one and divide it by the within. That's where that's coming from. And if I want to do that again, I'm just going to lock this here, and then I come down here, and then come down here, and that's it. Okay, so that's where, if I just double click this one here, you can see, look, it's 10.2 divided by 9.75. The F ratio you ideally want it to be different from 1. How different you need it to be is going to be dependent on your sample size and so on like that. And this is where, if you were to do everything manually, you would now go to your statistical tables. And Murdoch and Barnes is the tables that we'd often use over here in Ireland. You'd go to those tables and you'd find the corresponding p-value, but there are other ways of doing it. And just to kind of show, look, that everything we've done here is correct, I actually have the script set up in RStudio already of the data that we have here. And if I'm just going to, I suppose I had to convert, I'll just import there just so you can see what I'm importing. I'm basically importing the data that we had at the very start, the very top part of the cell. Okay, so I'm specifying A1 to G11, and then I need to convert it to a y, from a y to a log. I check normality and homogeneity variance, and predominantly passes all that. I think one group, maybe 2 groups are not normal. If I do a quick check there, yes, yes, no. So there's only one that wasn't, oh sorry, 2 that were deemed not normally distributed. If you look at the overall homogeneity variance, we're passing that. So basically, out of our 10 groups, 8 of them are normally distributed. The homogeneity variance is fine, so we should be generally okay to proceed with the ANOVA. And this is where we're just going to do the ANOVA. Obviously, mainly what we're interested in here is the result, and this is the result that we get back. And if we just look at maybe at a quick glance of, if we just wanted to kind of marry them up, just to see is everything okay. here we can see, look at the sum of squares, 351.5, 351.5. You can see the F ratio for the group is 9.013, and that's what we have. If I put that as an extra decimal place, we'd see that there, 9.013. The next one is going to be 0.462 in RStudio. If I put that in there, you're going to see 0.462 in our Excel as well. And then the last one is 0.046 in RStudio. If I put that as an extra decimal place, we have 0.046 here as well. Okay, now, so again, the purpose of just doing these videos here is I would feel that in research, if you find that you're doing a lot of ANOVAs, and again, I would feel that this is maybe more for the PhD student that might be heading towards a Vive at a later stage, that I would just feel it's kind of good to have a certain kind of a comfort when you're presenting your ANOVA results, that you actually know what's actually happening behind the scenes. I think that definitely comes across well in a Vive kind of situation. Okay, so look, that's why I wanted to kind of show this. It's not that I'm saying that you need to do this for all your calculations, definitely not. It's just more to understand that when you do an ANOVA in a statistical package, look what is actually happening behind the scenes, because it happens so instantaneously here. Like you can see when we did it in RStudio, it was done within seconds. Okay, so it's just what is actually being done there. Okay, for that. So look, that's it for this video. I'm going to do one more on the ANOVAs, which is going to be looking at the randomized block design. I suppose I should have said that at the start. For this video, TwoWay ANOVA, that is ultimately kind of seen as a factorial experiment. You'd see some disciplines would call it a factorial experiment. So here we have two factors and we're looking at the interaction between them. I'm going to look in my next video of where we have two factors, but there's no interaction between them. Again, no context to this. This is up to me or up to you as a researcher to kind of to be aware of, should there be a interaction or not. And what that would be called if there's no interaction is a randomized block design. And I'm just going to show you how to do the calculations for that for an ANOVA. And that would be the kind of probably just closing out this kind of, I suppose, section of videos that we have on the F calculations in Excel. But overall, I hope you're happy with it. I hope you find that it's a help. And like always on YouTube, if you are happy with liking it and sharing the video, it's great. If you actually have any comments on the video, I'd much appreciate that. I would often say it in my other videos that shared learning is really good. Okay, so if you have, I suppose, your own tips to what you might find improved your own understanding for doing the ANOVA calculations, then by all means, please share it in the comments below. And obviously, subscribe to the channel and you'll get updates when the next videos are coming up as well. Okay, but for the moment, all the best.